Okay, students, so let us continue. Let us start with the Nernst equation. Nernst equation. So, what do you mean by Nernst equation? Nernst equation now it's used to find the electrode potential of an electrode now if the concentration of the electrolyte is different. For example, now we finding the standard electrode potential by fixing the concentration of electrolyte as 1 molar. So if the concentration of the electrolyte is different, how can you find the electrode potential? So that was derived by Nernst, and Nernst equation is very popular. So let us go straight into the equation and how to find the electrode potential if the concentration of the electrolyte is different. So we have an equation E electrode which is equal to E electrode which is equal to E0 electrode minus RT by NF ln. Okay, here now consider the electrode reaction as general electrode reaction as Mn plus an electron reversibly gives M, where Mn plus in the aqueous state. So this is a standard reduction reaction for any electrode. If the metal ion is reduced to metal, then now how can you find the electrode potential? E electrode is equal to E0 electrode minus RT by N of Ln concentration of M, that is now concentration of metal divided by concentration of Mn plus. That's the concentration of metal ion. So that's the way you can find. This is popularly known as Nernst equation. Where now we know R is constant, universal gas constant 8.314 joule per Kelvin per mole, and M is the number of electron involved. Okay, it's the number of electron involved in the reaction, and F is the Faraday's constant. It is equal to 96500 coulomb, and concentration of metal that we are arbitrarily taking as unity. Concentration of metal we taking as unity. So we can now have another equation, and we converting ln. We converting ln into log. How can you convert ln into log? By multiplying by 2.303. So apply R, you will get now another equation, electrode which is equal to E0 electrode minus 0.05991 divided by N log 1 by concentration of Mn plus. So what are the changes we made? We applied the values, constant values. For R is equal to 8.314 and T is equal to absolute temperature. We considering the standard temperature as now as 298 Kelvin, and F is a Faraday's constant 96500, and we converted ln into log by multiplying by 2.303. So applied R, you will get the rearrange the equations is E electrode which is equal to E0 electrode minus 0.059 divided by N log 1 by concentration of Mn plus. If you want to not change the minus sign, still you can do E electrode which is equal to E0 electrode plus 0.0591 divided by N log concentration of Mn plus. So we just know minus change to plus means this will come out. So that also you can remember. So this is the equation to find the electrode potential of an electrode if the concentration of the electrolyte is different. So just apply the concentration here, you will get the electrode potential. What is E0 electrode? It's a standard electrode potential. We find it the standard electrode potential in the standard condition, fixing the concentration of electrolyte as 1 molar, fixing the pressure as 1 bar, and the temperature as 298 Kelvin. We are getting the standard electrode potential. We find it using a reference electrode like hydrogen. So that is now the equation. We can remember that is we call Nernst equation. Now consider if you have a Nernst equation for a particular electrode. Can you find the electrode potential of a cell? Yes. Let us think now Daniel cell. Daniel cell means no anode is our zinc and cathode is our copper, right? Cathode is our copper. So let us now find the electrode potential of zinc. Electrode potential of zinc will be equal to E Zn2 plus bar Zn. Let us try to find the electrode potential, or we will say no electrode potential of zinc electrode. E0 Zn2 plus bar Zn minus 0.0591 divided by n log 1 by concentration of Zn2 plus. This will be the electrode potential of zinc if you apply Nernst equation. And E copper 2 plus bar copper. This is the electrode potential to find the copper. E0 Cu2 plus bar Cu minus 0.0591 divided by n log 1 by Cu2 plus. So we find the electrode potential of zinc and copper. Now, how can you find the electrode potential of a cell? We know E cell is equal to E cell is always equal to E cathode minus E cathode minus E anode. So it is literally what electrode potential of cathode minus electrode potential of anode. So we know cathode is no copper which undergo reduction, zinc is anode which undergo oxidation. So E cathode minus E anode will give you cell potential. So you can find the cell potential if you know the electrode potential value of the anode and cathode, you can still find it. So let us have an equation for that. So E cathode minus E anode. So you have to do E Cu2 plus bar Cu minus E Zn2 plus bar Zn. So first you need to do now this part you can minus it. E0 Cu2 plus bar Cu minus E0 Zn2 plus bar Zn, which is nothing but standard EMF of this cell, because standard electrode potential of copper minus standard electrode potential of zinc will give you standard EMF. That's the maximum voltage that you will obtain when these two electrodes are connected, or we will say when there is no current is drawn from the cell, what is the maximum potential difference that we obtain. So that what EMF of the cell is all about. So standard EMF you can find. So and here 0.059 divided by n is common, so this we can take it as common, and here log a minus log a should be applied. Log a minus log b is equal to log a by b. So 1 by Cu2 plus bar 1 by Zn2 plus, which means Zn2 plus will come out. So the equation cell potential E cell will be equal to E0 cell minus 0.0591 divided by n log Zn2 plus bar Cu2 plus. So this is the way you can find the cell potential using Nernst equation. Now what are the data we needed? We want E0 cell. If no standard electrode potential of cathode and standard electrode potential of anode is given, you can find the cell potential, standard cell potential E0 cell, which is equal to E0 cathode minus E0 anode. That you can apply here to find E0 cell, and all you need the concentration of Zn2 plus and concentration of Cu2 plus. So if you generalize this, how can you say? So E cell will be equal to E0 cell minus 0.059 divided by n, where n is the number of electron involved, and a log concentration of oxidized state of anode divided by concentration of oxidized state of cathode, because Zn converted into Zn2 plus, so oxidized state is Zn2 plus, where Cu2 plus converted into copper, but the oxidized state is C2 plus, right? So that's the way you can generalize it. You can find the cell potential of any cell if you have this data. Now let us do some problem. For better understanding, let us do some problem. The first one they given, yes. A copper is placed in 5 into 10 raised to minus 3 molar copper sulfate solution at 298 Kelvin. Calculate the potential of the electrode at 298 Kelvin. Given E0 copper 2 plus bar copper is given, which is equal to 0.34 volt. So what you need to find? We find the electrode potential of copper you need to find. So what's our equation? E Cu2 plus bar Cu, that's electrode potential of copper you can find, which is equal to E0 Cu2 plus standard electrode potential of copper minus 0.059 divided by N log 1 by concentration of metal we taking as unity, so Cu2 plus. This you can apply. Now here N will be equal to 2 because number of electron involved will be Cu2 plus 2 electron gives Cu, so that will be equal to 2. And now one thing you can do, let Cu2 plus be on the upper side, so E Cu2 plus bar Cu. Standard electron potential of copper is given 0.34 minus 0.0591 divided by 2 log. So I'm changing minus by plus, so C2 plus will come up. Concentration of copper 2 plus is given 5 into 10 raised to minus 3. 5 into 10 raised to minus 3. So apply here. We know this is the form of log A into B. Log A into B is nothing but log A by B. So let us do this part. So log A by B, which is equal to log A plus log B. Here log 10 raised to minus 3 means is equal to minus 3 log 10. Log 10 is equal to 1, so this will be equal to minus 3. So you will get minus 3 plus log 5. You find the value of log 5, minus 3 plus log 5 will give you part of this answer. So apply here, now you will get the electrode potential of copper will be literally equal to 0.27201 volt. So that will be the answer. So let us do similar type of problem. Calculate the EMF of a cell. The cell representation they given Cu2 plus 0.25 molar, Ag plus 0.6 molar, Ag. Okay, so cell representation they given Cu bar Cu2 plus. Concentration of Cu2 plus they given 0.25 molar. And double bar represents salt bridge, and Ag plus concentration they given 0.6 molar, 0.6 molar bar Ag. What's the value they provided? The value E0 of copper is given, E0 of Ag is given. E0 of copper 2 plus bar copper they given, which is equal to 0.34 volt. E0 of Ag plus bar Ag, which is equal to 0.80 volt. So these two values very important to determine which is acting as an anode, which is acting as a cathode. Otherwise, you have to know the standard electrochemical series. So here silver having higher reduction potential value, which means that will be cathode. Here copper having lower reduction potential value, that means no copper acting as anode. Never think always copper is cathode. It depends on the standard electrode potential value. So first of all, let us write the cell reaction so that now you will know, you can represent, you can write the overall cell reaction, and we can go to the next equation. So we know copper is anode here, so copper gives copper 2 plus 2 electron. That will be the anode reaction. Then now cathode will be Ag plus 1 electron gives Ag. That is cathode reaction. Remember, this is not in such cases the number of electron released in the anode should be equal to number of electron gained in the cathode. So you have to make it equal, which means you have to multiply this whole equation by 2 so that it will be equal. So what you will get, 2Ag plus 2 electron gives 2Ag. 2Ag plus 2 electron gives 2Ag. So that 2 electron will be cancelled. So overall reaction will be Cu plus 2Ag plus gives Cu2 plus 2Ag. That will be the equation. Now let us let us apply Nernst equation and find the EMF of the cell. So first let us write the equation E cell, which is equal to E0 cell minus 0.0591 divided by N. N is 2 here because 2 electrons are involved. Log concentration of oxidized state of anode. Here concentration of copper 2 plus. Bar concentration of oxidized state of cathode. So it will be Ag plus. Remember 2Ag is there. So stoichiometry always should write as power. So that should not be forgot. Here Ag plus square. So apply here. Now here you will get the cell potential. E cell will be equal to E0 cell. Let us find E0 cell first because standard electrode potential of silver and copper is given. So standard electrode potential of cathode minus standard electrode potential of anode will give you E0 cell, which is equal to 0.80 minus 0.34. How much it will be? It will be 0.46. So 0.46 is the standard EMF for the cell. So we find E0 cell. Now you can find E cell. E cell, which is equal to 0.46 minus 0.0591 divided by 2 log concentration of Cu2 plus, that we already given 0.25 divided by concentration of Ag plus is 0.6. Don't forget to make it square. So apply here, you will get an answer around 0.4646. 0.4646 volt. That's the way you can find the E cell potential of a cell if the concentration of the electrolyte is different. Similar type of questions are given. Please go through it. You can find it. Let us do one more. So here E0 of cadmium is given. E0 of Cu2 plus bar Cd cadmium is given. It is minus 0.40. E0 of copper is given, which is equal to 0.34 volt. So that is the reduction potential value of standard reduction potential value of cadmium and copper is given. Represent the standard cell that's set up from the electrode. Give the electrode and the cell reaction and calculate the standard EMF of the cell. So we have to find the standard EMF of the cell and cell reaction. So from this value you can understand this will be anode, this will be cathode because higher reduction potential value for copper. So let us write anode reaction. Cd gives Cd2 plus 2 electron. This is our anode reaction. And CO2 plus 2 electron gives Cu. This is our cathode reaction. So overall reaction will be Cd plus Cu2 plus bar gives Cd2 plus copper. This will be our overall reaction. Okay. Now apply next equation. You can find the next equation. If first you can find E0 cell, which is equal to E0 cathode minus E0 anode. So 0.34 minus 0.40, which means this will be plus. So net value will be 0.74, right? 0.74 volt. Oh, this is the equation actually now. They ask you to find the standard EMF of the cell only. The concentration of electrolyte is not given, which means no, you doesn't need to find the cell potential which having no different electrolyte concentration. So here the concentration of electrolyte is actually 1 molar. So this is 1 molar. This is also 1 molar. So actually the E cell will be equal to E0 cell will be here as well, because standard concentration of electrolyte is 1 molar, means E0 cell will be the cell potential. So 0.34 minus of minus 0.40, which is equal to 0.74 volt. So that's the way you can find the cell potential if the concentration of electrolyte is different. So apply such equation, you do some more problems and practice yourself. Thanks for listening this class. Let us meet in the next session. Thank you.